Good morning, everyone, from the live inside the weather office here in Reno. I actually just grabbed this screen capture just a few minutes ago just to give a nice little flavor of what everyone hopefully is missing since we can't be together today here in Reno. So as Don showed earlier today, winds are pretty bad around the Sierra, seems like almost all the time. So we do have a lot of certainly turbulent events that we deal with, and then this set of east wind events is a slightly more specific category of events that we have to deal with. And most of these actually don't really impact the Reno airport too much, but I'll kind of get into that a little bit. So as Dawn alluded to earlier, most days flying in Reno, Tahoe, and most of the airports in the Sierra are kind of like the image there on the left. A few bumps here and there, but we do have those rather more significant events where you get the scene a little humorously tongue-in-cheek there on the right. And I think Dawn even showed this in her presentation about the aircraft almost rolling the Dash 8 on a specific event. So when I kind of sit about and think about forecasting in the area, and I guess I'm a little coming up on 20 years of being a forecaster in the region, the thing I think that really keeps me up at night when it comes to aviation is definitely these more localized bursts of high intensity wind, so the large graphic you're seeing here is from atop Rattlesnake Mountain, which is just south of the Reno airport. You can see the runways there on the left side of the image, and then on the right is essentially a 2x4 that has been thrown through the side of a stucco building. And this was an event back in 2014, early March 2014. It was along a cold front, and at this time, this is really hits home as how localized these little bursts of wind that we do tend to get around the region. So where this damage occurred was generally within a mile of the end of the east-west runway, which is used quite frequently for general aviation purposes. So these types of things are pretty common. They do happen quite often. Usually, and they're really difficult to predict. These small areas, we have the idea, today could be a windy, big, low-level wind shear day, but to see this level of damage that close to an airport is pretty eye-opening here for especially in the Reno area. So, getting back to our kind of east wind events, these are a little less common. They do happen a few times a year, but not the magnitude that we usually see in the more typical south to southwest, strong wind events that we typically get any time a winter storm comes into the Sierra or even somewhere into the West Coast. So, the images here are actually from back in February. We did have a pretty strong east wind event that impacted the Tahoe Basin down to about probably the Sonora Pass area. For those that are familiar with where Sonora Pass, it's one of the winter closures in the Sierra, and the image there on the right or on the far left is actually Tahoe. We do get really large waves on the Tahoe from these events. I think sometimes on occasion the Coast Guard will be like, hey, that was probably like an 10 feet wave event on the lake, which doesn't tend to be too impactful at times unless the lake is, unless Tahoe's got a lot of water in it. Then we open ourselves up to a little bit of near lakeshore damage, especially more boat docks and boat launches that might get impacted by that. The bigger impacts to these stronger wind events are down trees, since trees aren't quite used to, they're if you go up there and spend a lot of time in the high Sierra, you'll see which way the wind blows just by how the trees grow. So when they're loaded on the other side, they tend to fall a little bit easier than they normally would. So tree falls, those lead to some power outages, and depending on time of year, those power outages could actually and trees downing power lines can actually start wildfires. So that's kind of somewhat of a secondary, or could be a really significant concern with some of these larger events. So the first really big event that we kind of were able to capture in the Sierra was back in started about the afternoon of November 31st, 2011, but the big damage occurred early in the morning on December 1st, 2011, and this is Devil's Post Pile, which is down by Mammoth Mountain. This is about a 3-hour drive south of Reno, fairly close to the Mammoth Lakes Airport, which is probably probably even a more gnarlier place to fly in and out of than Reno. If you've never gone in and out of there, I wouldn't recommend it, especially on a windy day. So this event, a lot of really old growth trees. It was almost 5,000 trees were lost in this event, where we had winds up above 150 miles an hour. And this is kind of one of those events where we thought, could we see a 200-mile-per-hour gust somewhere in the Sierra? Could we have an instrument in the right spot at the right time to actually record that? And the reason we thought about this one, because the winds on top of Mammoth Mountain were actually, and we didn't know this at the time, and this kind of fell out of this event, is there was this rather, let me put a pointer around here, so you can kind of see where the green line here, or the green dots, are the wind gusts from the top of Mammoth Mountain. They're flatlined at about 150 miles an hour, and when we kind of interviewed and talked to the ski area down there after this, they found out, like, oh, hey, we never thought winds could be that high or that strong, so we just capped our instrumentation of reporting anything over 150 miles an hour. Well, with the damage of those trees, some of those trees had been around for, probably a couple 100-year-old trees that we had lost. When we did the site survey, we thought, probably the high end was somewhere close to 200 miles an hour. So this next event that we just had recently back in July was captured well by the Kirkwood ski area, and this was back on February 9th. And you can kind of see a blown out window here and a truck there on the left. And usually we start to see winds up above 90 miles per hour that actually will blow out a car window. And the other one here on the right, you can see there's been a piece of one of the lift chairs that has actually been torn off. The actual chair, this is from when you get winds that high, these chairs just start swinging in the breeze, and then they start slamming around, and you start kind of breaking lift chairs. So what ended up happening on this one is we got a measurement of 209 miles per hour out of the instrument on top of Kirkwood. So at this point, it's an unverified wind gust. Usually when you see gusts this high, it goes through a kind of a verification process to make sure, hey, is that legitimate? Because if this was a legitimate observation, it would be a state record for highest recorded wind gust in California. So we don't think this is going to go through that verification process for a number of reasons. Some ski resorts tend to be a bit protective of their wind data at times. They're sometimes a little unwilling to kind of let that be out there. I think that there's that stigma that ski resorts really don't want to be, hey, we don't want to be known for a windy spot. So there's some slight issues there, but to us the observation looked pretty legitimate. So we'll just kind of leave it at that. But the question we usually get is, hey, these mountaintop IWAWS, what kind of equipment is actually up there to measure these really strong and potentially severely impactful wind events? So there's a company called Taylor Scientific Engineering, and they've been around for quite some time building these rather very specific mountaintop instrumentation. So the image here on the right, you can kind of see the anemometer there. These are actually heated, so they do not freeze over or rime up, because wind obs are extremely important for ski resorts, for not just lift safety and on mountain safety, but essentially for avalanche control too. So it helps them figure out how much snow loading could have occurred. So this is we did a site visit here after that Kirkwood event, and these are the kind of the pictures we took from that. And I would say most of the ski areas around the Sierra and Tahoe Basin have one of these on top of them, and these are pretty well tested. And the actual current California state record, which is 199 miles per hour on squall, that occurred from a southwest wind event back in February 2017. It was actually one of these instruments that actually captured that event too. So that just kind of gives you an idea of the equipment that's up there. It's got to be really specialized and you know, a really unique set of to be able to withstand that kind of duration of wind, especially some of these wind events are up there that'll last for a day or 2 days, or even in extreme events 3 days at a time. So back to the actual, okay, so what causes these type of events? Usually these are almost post-winter storm, if you will, type events. Go back that way, there you go. So low pressure kind of usually passes south of the Tahoe Basin, or, you know, it's tracking through Southern California into Southern Nevada, and, you know, usually head towards Arizona at this time. And then we usually get this strong, you know, northeast to southwest oriented jet on the backside of the low. And, you know, a lot of people who are kind of familiar with offshore wind events in California, this is also a fairly decent setup for Santa Ana winds or all those other well-known east wind events that really impact the, you know, the coastal areas of California, which is a really huge fire danger issue for them. So the other part of this, so as this low moves through the areas, a surface high, and usually in the winter, a really big, strong dome of cold air sets up over Nevada. And from there, you get this really strong offshore gradient. And really what that does, that gradient usually sets up right along the Sierra crest. So here's that gradient. Here's that image from the kind of the Kirkwood. As we kind of search through the model data, so to kind of orient everyone here, Reno is about right there. Tahoe is here. Kirkwood is right here, which is just where we saw, fairly close to where we saw those really, the models picking out these 77 knot winds just below ridge layer. And in these situations, if we were to take a cross-section, so if we were to slice the atmosphere right in half about along that line, it would look a little something like this. So just to kind of explain what we're looking at here in this graphic, the brown areas, that's the terrain. The blue area, the blue kind of line arrow here is the path that you know, air would essentially take as it travels across the Sierra from east to west. And these events, the pink lines kind of show a really strong downward motion. So what we're seeing here is this cold air kind of sitting out over the Great Basin, warmer air over the lower valleys of California, and you get this kind of almost a funneling effect in between the two. You combine it with a little bit of downward motion. That's where you get your warming and drying air, and we start to see these really, you know, we start to see really strong wind speeds that models really have a difficult time to predict, because they do occur on scales that are essentially below model resolution. So in the end, when you kind of think about this, what we're doing is as we're forcing this air in between the cold dry air, or the cold air on one side of the Sierra and the warm air on the California side of the Sierra, it's almost like putting a nozzle on the end of a garden hose, kind of the Venturi effect, and you're really squeezing all that air into a small confined space. Essentially, the Sierra is the garden hose, and you really start to get these extreme, unusual wind events. Now, fortunately for us, these really high wind events on the east that come from the east that occur, you know, maybe once a year, maybe once every other year. The really extreme ones, from what we can tell, happen maybe once every 5 or 6 years, perhaps a little larger gap than that. It just depends if the right setup's coming at the right time. So that's all I've really got for you guys. If you have questions, I will certainly be happy to take those.
All right, Brian, we do have one question here. So just curious, how often are the ski lifts in that area closed due to high winds? Do you have direct communications with ski resorts?
We do. We actually we spend a lot of time with ski patrol, more likely ski patrol, since they're kind of more concerned with on mountain safety. And it's winds usually from my experience from skiing, it comes down to the ski resort's call. But it seems like once we see winds up above, that 50 knots is when they start looking at closing